Example 1, find the first three terms in ascending powers of x of the binomial expansion of 3 plus 2x to the power of 8, giving each term in its simplest form. Now, binomial expansion is a useful method for expanding brackets of higher powers. For example, here we've got a power of 8. We wouldn't want to sit there and expand 3 plus 2x 8 times by hand. Instead, we're going to use the binomial series formula, which is given to you in your formula book. This is a copy from the EdXL book, but you'll be given something similar no matter what exam board you use. And really, it's just a case of substituting into the formula. So here we've got a, and in the question a is 3, b in this case is 2x, and n, the power with which we want to expand, is 8. So now we can just carefully sub into the formula. So 3 plus 2x to the power of 8 is going to be approximately equal to a to the power of n, so 3 to the power of 8, plus 8 choose 1 times 3 to the power of 7 times 2x, plus 8 choose 2 times 3 to the power of 6 times 2x squared. And then that will actually be the first three terms, but I'm just going to show you the next one so we can talk about the pattern. The next one would be 8 choose 3 times 3 to the power of 5 times 2x cubed. Now the pattern is these powers, the powers of 3, go down by 1 each time, starting from 8, and these powers, the powers of 2x, go up by 1 each time. Technically starting from 0 at the very first term, and then here's an invisible 1, and then 2 and 3 and so on. You also may have noticed that the powers in each individual term add up to 8. That's not a coincidence. That's a good way to check that you're doing the right thing, because we want them to add up to 8 because the original question had a power of 8. Formula in the formula book is useful as a reminder, but I find that it's also helpful to know the pattern for binomial. After you've got that all written down, it's a case of just typing things into our calculator. So for the first term, 3 to the power of 8, we just type that in and we get 6,561. For the second part, you can actually type this all in one go, apart from the x. So you can type that as 8 choose 1 times 3 to the power of 7 times 2. And when you do that, you get 34992x. For the next term, we'll do 8 choose 2 times 3 to the power of 6 times 2 squared. Really important that you also square the 2 there. And that will be 81,648 x squared. And then we don't actually need the fourth term for this question, but if you did want to work it out, it would be 8 choose 3 times 3 to the power of 5 times 2 cubed, and then x cubed. But the answer in blue there is all we need. Example 2, more challenging. Find, in simplest form, the coefficient of x to the power of 5 in the expansion of this. Now, the reason this is more challenging is it's more of a problem-solving question. We need to recognize that these are two brackets times together, but the second bracket is to the power of 6, so we could use a binomial expansion for the second bracket. And if we were to do that, we would have the 5 plus 8x squared from the first bracket, and then a bunch of terms from the second bracket once it had been expanded. At some point in that binomial expansion, you're going to have something x to the power of 3, and you're also going to have something x to the power of 5, amongst other terms. Now, the reason I've called those two out in particular is because we're looking for the coefficient of x5 overall. The only way we're going to achieve that is by doing 5 times something x to the power of 5, and also 8x squared times something x cubed. Both of those would give us x to the power of 5 overall. So we don't need to do the whole expansion. We can pinpoint those exact terms that we want to work out. So let's find those terms in 3 minus a half x to the power of 6. If we use the formula, that's going to be something. And then the interesting one is 6 choose 3 times 3 cubed times minus a half x cubed, because that will give us our x cubed term. And then the other interesting one is 6 choose 5 times 3 to the power of 1 times minus a half x to the power of 5. That will give us our x to the power of 5 term. Let's work these out, simplify them. So in the calculator, we can type 6 choose 3 times 3 cubed times minus a half cubed, and that gives us minus 135 over 2 with our x cubed. And then for this term, we can do 6 choose 5 times 3 to the power of 1 times minus a half to the power of 5, and that gives us minus 9 over 16 x to the power of 5. So we have found the relevant values here. I'll just put them inside the bracket. Now we can go back and answer the question, what would be the coefficient of x to the power of 5 in that overall expansion with the 5 plus 8x squared? It would be 5 times minus 9 over 16 plus 8 times minus 135 over 2. Type that into your calculator and you get minus 8685 over 16 for your final answer. Last example, find the first 3 terms in ascending powers of x of the binomial expansion of that. And then part B, use your expansion to find an estimate for the value of that. Part A, more of the same. Let's use the formula. 2 plus x over 2 to the power of 6. According to the formula is this. I'm only going to worry about the first 3 terms because that is what was specified. I'm going to simplify this by typing into my calculator, being careful with brackets. And I get this, 64 plus 96x plus 60x squared. That's it for part A. Part B, we're going to use that answer to find an estimate for the value of 2.05 to the power of 6. Now, on first glance, it might not look relevant, but if I write 2.05 to the power of 6 underneath the algebraic expression, hopefully you can see then that we could set 2.05 equal to 2 plus x over 2, and then we'd be talking about the same idea. So let's do that and solve for x. X would be 0.1. All that's left to do then is sub in x equals 0.1 into your expansion from part A. So it looks like 64 plus 96 times 0.1 plus 60 times 0.1 squared. When you do that, you get 74.2. And that's all they're looking for part B. If you want, you could check that your answer makes sense by actually typing in 2.05 to the power of 6 in the calculator. And when you do that, you get 74.22 and so on. So it looks like we've done it right. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks and see you next time.